GCMS is an analytical technique used in a variety of different forensic disciplines. For example, drug chemistry, toxicology, and trace chemistry. A chemical analyzer is used to detect and identify chemical compounds of interest, which can include drugs, poisons, fire debris, explosives, or gunshot residue. But what exactly is GCMS, and how does it work? This video will briefly explain what both are and how they are applied in forensic science.
Gas chromatography, or GC, is used in forensics to separate a sample into its individual chemical components, in some cases isolating all of the forensically relevant compounds from one another so that individual chemical identification can occur. The forensic scientist must first perform one of many sample preparation techniques available to make the sample suitable for GC chemical analysis. Most of these preparation techniques involve dissolving the sample into an organic solvent. After sample preparation, a microliter amount of the prepared liquid sample is injected into the injection port of the GC device, where it's immediately volatilized and mixed with a carrier gas. This gas serves to move or push the solutes forward down the capillary column in what is known as the mobile phase. This column provides a surface for the components in the sample to interact with. This is called the stationary phase, and it allows the components to slow down, allowing for separation to occur. The different chemicals in the sample separate based on their volatility and mass. Each peak that appears within the total ion chromatogram represents a different organic chemical component. Mass spectrometry, or MS, is used to produce spectra, or unique spectrum, of each of the individual components within the sample, thereby providing their chemical identity. MS works by ionizing chemical compounds to generate charged molecular fragments and measuring their mass to charge ratios. After passing through the GC column, the molecules are blasted with electrons at 70 electron volts, which cause them to break into unique fragments that turn into positively charged particles called cations. These ions travel through an electromagnetic field that filters them based on their mass. The particles must be charged to pass through the filter. The instrument's detector amplifies and then counts the number of ions associated with that specific mass. That information is then sent to a computer and a mass spectrum is created, showing the number of ions with different masses that travel through the filter. Using a computer algorithm, this generated spectrum is then compared and matched against the library database containing known chemical MS spectra. If a match is found within the spectral database, the unknown chemical is identified.